So this section is about a rational expression, okay, and we start with an example. And the question here is that for what values of x the following rational expression is defined. So rational expression is if you have your variable in the denominator, then that is the rational expression, okay, or fraction. You all have seen a fraction, right? So that is the rational expression. Now here we have a rational expression x plus 1, which is the numerator, divided by x minus 3 times x minus 5, which is the denominator. Now, before this one, okay, so let's take very simple example. So let's say we have a rational expression 2 divided x. So this is our rational expression. Now, can you think of a number for x for, okay, now for what value of x this 2 over x is undefined? Undefined means we have a real number, right? So we have a number from negative infinity to positive infinity. So this is the real number. And let's pick some number from this set and substitute for x. Now, do we always get a real number for every real number? So here you have the option to select any number from negative infinity to positive infinity for this x, okay? And once you substitute the value of x, do we always get a real number for every value of x? Okay, let's pick a value of x. So let's, for example, our x is 1. Let's pick x equals to 1. So what will be 2 over x equals to? It is 2 over 1, which is 2. And 2 is a real number. So our rational expression is defined for x equals to 1. Now let's take x equals to minus 2. If x is equals to minus 2, our rational expression is 2 divided by minus 2, which is negative 1. Negative 1 is a real number. So it means rational expression is defined for x equals to negative 2. Now what happens if you pick x equals to 0? So we end up getting 2 divided by 0. And what is 2 divided by 0? It is undefined. We can't have a 0 as a denominator, okay? So this is not a real number. This is undefined. So if you have a 0 in the denominator, it's always undefined. We can't have a 0, okay? It is not a real number. So for the value of x equals to 0, so when our x is equals to 0, this rational expression is undefined. Now, this is what we have in our example. We have x plus 1 divided by x minus 3 times x minus 5. Now, can you think of a value of x such that we get 0 in the denominator? For what x value we get a denominator equals to 0? X equals to 3 and 5, right? So if we pick x equals to 3, so if we have x equals to 3, then our rational expression is 3 plus 1. You substitute 3 for every x. 3 minus 3 times 3 minus 5. So this is 4, 0 times minus 2, and that is 4 divided by 0, which is undefined. So for x equals to 3, this rational expression is undefined. In the similar way, what is the another value of x? If you pick x equals to positive 5, then we get 5 plus 1 divided by 5 minus 3 times 5 minus 5. And this is 6 divided by 2 times 0, 6 divided by 0. And this is undefined. So for x equals to 5, the rational expression is undefined, okay? So if you have a rational expression, then the x that make denominator equals to 0 is always undefined, okay? The number that make denominator equals to 0 is always undefined, okay? And this concept will be used when we are asked to find the domain of a rational function, okay? So here every number, okay, other than positive 3 and negative 5, it does not matter what number you pick other than positive 3 and positive 5, we always get a real number from this expression, Okay, so every number other than positive 3 and negative 5 are the domain for this rational expression, and we will talk about domain in detail. Okay, now let's go to the next example. So here we are asked to multiply the rational expression. Okay, in order to multiply, we multiply numerators together and we multiply denominators together. Okay, this is same as multiplying the fraction. So this is, you multiply numerator 3a times 24 divided by, yeah, you can multiply 3 and 24, right? So what is 3 times 24? 72 times a divided by 8 times 6, that is 48a cube. Now let's simplify. Let's have our final answer in the simplest form. Now how can we simplify? Okay, now in order to simplify, let's factorize our numerator and denominator. Okay, and it will be easy for us. If we factorize numerator and denominator, we can cancel the common factor from numerator and denominator. Now how can we rewrite our 72 in a factor form? So 72 is 2 times 36 is 72, right? So 36 is 2 times 18, 18 is 2 times 9. Okay, so each 72, 2 times 2 times 2 times 3 times, okay, that's 9 times 2, 18 times 2, 36 times 2, 72 times 8. So you factorize your numerator. In the similar way, how can we rewrite 48 in a factor form? So 48 is 2 times, so that's 24, you again divide by 2, you get 12, you get 6, you get 3. And a cube is, what is a cube? A times 8. So we factorize our numerator and denominator. Any question in factorization? Now we have our numerator in a factors form and denominator in a factor form, and if this is the case, we can always cancel the common factor. So these 2 and this 2 is common factor, it cancel out. Similarly this 2 common factor, this 2 common factor, this 3 and this 3 is a common factor, a and a is a common factor, it cancel out. Now the remaining, what do we have in the numerator? We have 3 divided by, and in the denominator we have 2a times a square, and this is the final answer. If you are asked to multiply, you write down your numerator in a factor form, write down your denominator in a factor form, then you look for the common factor in the numerator and denominator. If you have a common factor, you can cancel. Okay. Now in the similar way, let's do number B. So in number B, we have a 2 rational expression. So this is one, this is another, and we are asked to multiply. So let's factorize our numerators and denominators. Now how can we factorize, or what is the method to factorize this trinomial? What method do we use to factorize trinomial? There are the 2 methods. One is FOIL and the other one is AC. Now for this one, which one do we use? FOIL, because the coefficient of each square term is 1. So let's multiply, sorry, let's have a 2 factor. So let's have a 2 factor. So what should be the first term so that its product is x square? X. Now you have to think of a 2 number, okay, whose product is -6 and sum is coefficient of x, which is +1. Think of a +3 and -2. Okay, so if you multiply +3 and -2, you get -6, and if you add +3 and -2, you get +1. So that one is from coefficient of x. Okay, so we have +3 and -2. Okay, now let's factorize our denominator x square minus 4. So what is that? Now we have a binomial, right? And if we have a binomial, you look for 3 different cases. Is this the sum of cube terms, difference of cube terms, or a difference of square term? difference of square term. So let me do here. So we have x square minus 4. We have x square. We can rewrite 4 as a 2 square. Now you compare this with a square minus b square. Your a is x, b is 2. Now you substitute in the formula. The formula is a plus b times a minus b. You do not need to memorize this. It will be given to you. Okay. Now you substitute your a equals to x and b equals to 2. So we have x plus 2 times x minus 2. So this is the factor for x square minus 4. Now in the similar way, since we are multiplying, so I can just write all the numerators together. So we have x plus 2 square. Now how can we rewrite x plus 2 square in a factor form? That's right, x plus 2 times x plus 2. Now we have x squared plus 9. Now, is it difference of square, sum of cube, or difference of cube? None, right? So it means we can't factorize, so you write down this as it is. If you have a sum of a cube, difference of cube, and a difference of square, then you can factorize. Other than that, you just write down that as a one factor. Okay, now we have our numerator in a factor form. Okay, so we have a factor form. In the denominator, we have a factor form. Now you look for the common factor and cancel out. So we have x plus 2 and x plus 2 common factor. It cancel out. We have x minus 2 common factor. Okay. Now the remaining here, we have x plus 3 times x plus 2 in the numerator, divided by x square minus 9, sorry, not minus 9, positive 9 in the numerator. And this is our final answer. So if you have the idea of factorization, simplifying the rational expression is not difficult. You factorize numerator, you factorize denominator, look for the common factor, cancel it, and write down the remaining factor. That is your final answer. Yes.
Can't you write 9 as 3 squared?
You can, but okay, now now here we have x squared plus 9. So you can write 9 square as a 3 square. But now if we go back to the factorization, so we have to have 3 cases. Now we have 2 terms, right? Now the 2 terms has to be difference of square, not a sum of square. Okay, so if we have a difference of square, sum of cube, difference of cube, then we can factorize using this formula. But in our case, so here we have a sum of square, so we can't factorize.
Why can't you factor sum of the square?
I'm sorry?
Why can't you factor sum of the square? Like what?
Okay, now there is a way. Okay, so the only way to factorize is that, so we can rewrite this as a 1 times x squared plus 9. Okay, like for example, if you think of a 7, now how can you factorize 7? The only way to factorize 7 is 1 times 7, right? So in the similar way, so x squared plus 9, the only way to factorize x squared plus 9 is 1 times x squared plus 9. So this is in the simplest form. Okay, so similarly, for example, let's say you have x minus 2. How do you factorize this? If you already have your polynomial in a simplest factor form, you can't factorize. The only way to factorize is you just write down 1 times x minus 2. Like if you have a prime number, so let's think of 2. How do you factorize 2? The only way to write 2 as a product form is 1 times 2, right? So 2 is a prime number. In the similar way, if you are asked to factorize 19, the only way to write 19 as a product of number is 1 times 19. In the similar way, so we have x minus 2. Okay, the only way to rewrite x minus 2 in a product form is 1 times x minus 2. So in this course, you will see. So if you find, okay, you look, so here, so these are the cases that you have to look. So if you have the difference of square, sum of cube, difference of cube, you can factorize. Okay, if you have a trinomial in a quadratic form, okay, then you can factorize. And if you have 4 terms we might. So it's not always that we can factorize, but we can just try to factorize. But if you have your polynomial in a simplest form, then we could not factorize. The only way to factorize is writing one time that expression. Okay. Okay. Any question up to here? Okay. Now the next here we have to add fraction. Like we have to add rational expression. I know most of you hate fraction, rational expression, okay? But once you have the idea of factorization, then you should be very good, okay? Now the next we need here is a least common denominator, and finding least common denominator is that we have to find the simplest expression that includes all factor of each denominator, okay? And we will take an example here. Okay, so here, so we have x plus 4. So we have this rational expression and this rational expression. What is the major difference between this a and this b? I know those expressions are not same. Now what is the other difference here? So we have a two rational expression here, and here we have a two rational expression. In this, what sign do we have in between two rational expression? So what sign? So in between this rational expression and this rational expression, what sign do we have? We have multiplication. And if you have multiplication, you multiply numerators and denominators. Okay. Now in our case, we have an addition here. Okay, and in number B we have a subtraction. If you are adding or subtracting, we always need to have a common denominator. Okay, it's same as a fraction. If you are multiplying fraction, you multiply numerators together, multiply denominators together. But if you are adding or subtracting fraction, you must have a common denominator before you add your numerator or subtract your numerator. Okay, now so in here, first case, do we have a common denominator? Okay, we do not have common denominator, so we need to find the common denominator. So in order to find common denominator, so let's write down each denominator. So we have this denominator, so let's write down this denominator, 3x plus 6. And the next denominator is x squared plus 7x plus 10. So this is our x squared plus 7x plus 10. Our target is finding common denominator. Now, in order to find common denominator, you have to factorize each denominator. Now, let's factorize 3x plus 6. What is the first step of factorization? Looking for the common factor in each term. Now, do we have that common factor? What is that common factor? 3. So, let's factor out 3. So, 3 is the common factor. Now you divide 3x by 3. So you divide 3x by 3 and write down inside the parenthesis. 3x divided by 3 is x. You divide positive 6 by 3. Positive 6 divided by 3 is 2. So 3 times x plus 2 is a factor for 3x plus 6. Now in the similar way, let's factorize next denominator. What method we will use here? Yes, we use FOIL method. What should be the first term so that its product is x squared? It has to be x. Now, think of a two number whose product is positive 10 and sum is positive 7. Plus 5 plus 2. So we have plus 5 plus 2. Now let's find the common denominator. Once you have your denominator in a product form, we can find the common denominator. Okay. And in order to find the common denominator, so write down the factor which is common in both numerator. Which is the factor common in both numerator? X plus 2. You write down that factor once. So write down x plus 2 once. Okay, do not write twice. Just write down once. If you have common factor, write down once. Now, do we have any other common factor? No. But we do have the factors which are not common. So we do have this remaining factor. Now you write down this all remaining factor. x plus 5, and this is your common denominator. Okay, we have to make our denominator as a x plus 2 times 3 times x plus 5 before we add our numerator. Okay, now let me write down the problem here. So we have x plus 4. We can write 3x plus 6 as a 3 times x plus 2 plus 2x plus 1 divided by, we can write x squared plus 7x plus 10 as a x plus 5 times x plus 2. Okay, do you have any question up to here? We factorize each denominator and we find the common denominator, and I just copied that question and I had the denominator in a product form. Okay, that's the only difference here. Okay, I need to have a parenthesis here. Now our target is making each denominator as this common denominator. That's our target. Now in order to make this common denominator, from here what factor do we have to pick to multiply numerator and denominator? What is missing? So if you compare, so you compare this, okay, you compare this new denominator with this common denominator. Which factor is missing? X plus 5 is missing, right? So you use that factor to multiply your numerator and denominator. So multiply the numerator and denominator by x plus 5. In the similar way, we have this denominator x plus 5 and x times x plus 2. You compare this denominator with the common denominator, and which factor is missing? 3 is missing. So you multiply numerator and denominator by 3. So let me rewrite this. So in the numerator we have x plus 5. Make sure to have parentheses if you have more than one term. Okay, x plus 5 times x plus 4 divided by, our denominator now is x plus 5 times 3 times x plus 2 plus 2x plus 1 times 3 divided by x plus 5 times x plus 2 times 3. Now do we have our common denominator? Now is our denominator exactly same for both rational expression? If so, we can add our numerator. So let's go ahead and add the numerator. So we have x plus 5 times x plus 4 plus, I can just write 3 in front, it's still same, 2x plus 1 divided by x plus 5 times x plus 2 times, let me write 3 in front. Okay, now here just let's take this as our final answer. You can still simplify. Okay, you can multiply x plus 5, x plus 4, you can distribute 3, and you can look for the like terms and have your answer in a simplest form. But for right now, just let's take this as a final answer. Okay, so if you understand finding the common denominator, that's enough. Can I start next example? Okay, so here our denominator is not same and we are finding the difference. If we are finding the difference or a sum of rational expression, we must have a common denominator. So let's write down each denominator. We have 4 minus 2x, and the next denominator is x squared minus 4. We factorize each denominator. Now, how can we factorize 4 minus 2x? Do we have a common factor in each term? What is that common factor? 2. Factor out 2. So 4 divided by 2 is 2, minus 2x divided by 2 is minus x. Now what about x squared minus 4? we already had a factor for x square minus 4, right? I think in our previous example. So yeah, so here x square minus 4, it is x plus 2 x minus 2. So x plus 2 x minus 2. Now let's find the common denominator, and in order to write down the common denominator, look for the factor which is common. Now which factor is common? Okay, now yeah, 2 minus x and x minus 2 is not same, right? But here, is there any way we could make it same? What is the difference? Like if we compare 2 minus x and x minus 2, what is the major difference? Their sign is just opposite, right? So in that case, what we can do, we can factor out negative from this expression. Okay, so let me just write down 2 as it is. So if you factor out negative from positive 2, we have negative 2. And if you factor out negative from negative x, we have positive x. You switch sign if you are factoring negative. So this is negative 2. Let me write down positive x first, then negative 2. Bless you. Now we have a common factor, x minus 2 and x minus 2. And you write down this common factor once, x minus 2 once. Now, do we have any more common? Do we have any more common factor? So we are looking this portion and this portion. We have x minus 2 common, so we write down once. Now we don't have any more common, but we do have more factors. So write down every remaining factor. So write down negative 2. Let me write down in front, okay? And the next factor is x plus 2. X plus 2. So this is our common denominator. Now let's rewrite our rational expression here. So we have 3x divided by 4 minus 2x. And let's use this, okay? So that is negative 2x minus 2 minus x plus 5 divided by x square minus 4 is x plus 2 times x minus 2. Our target is making this denominator same as common denominator. Now you compare. So what factor is missing? So what factor is missing from in this denominator and in this common denominator? Which factor is missing? So we have negative 2, negative 2. We have x minus 2, x minus 2. And x plus 2 is missing. So you multiply numerator and denominator by x plus 2. Now in the similar way, so let's compare this denominator with this common denominator. Which factor is missing? We have x plus 2 here, we also have x plus 2, we have x minus 2 here, we have x minus 2. So the missing is negative 2. So you multiply your numerator and denominator by negative 2 and make sure to have parentheses. Now let's rewrite this. So this is x plus 2 times 3x divided by x plus 2. Let me write down negative 2 in front. X minus 2 minus, x plus 5, and make sure to have parentheses, time minus 2 divided by, let me just write down negative 2 in front, x plus 2 x minus 2. Now if we compare our denominator, they are exactly same. And if this is the case, we can write our numerators together. So we have x plus 2, 3x minus x plus 5 minus 2 divided by our common denominator, negative 2 times x plus 2 times x minus 2. You can still simplify, but That's something we can do very easily. Okay, so let's take this as our final answer, but there is always to have our final answer in the simplest form. Okay, you multiply x plus 2 3x, you multiply x plus 1 x plus 5 negative 2, look for the like terms, add, subtract, and you get the final answer. Okay, this is a lot, but in our chapter 1 there is a rational expression. Okay, we will just revisit this topic. Okay, do not worry, and I do have a worksheet and we'll practice more examples. Okay, now let's do the last example from this handout. And in this handout, so in the last example we are asked to simplify complex fraction. Now why this is complex fraction? What do you think? Yeah, so we have a fraction in a numerator and a fraction in a denominator, right? So our numerator is this fraction, and we have this fraction as a denominator. Okay, now, and if you have a complex fraction, we can always simplify. For that, you just write down your numerator as it is. Our numerator is x squared minus 4 divided by 2x plus 1. Write down your numerator as it is. Then next, multiply that numerator by the reciprocal of denominator. Now what is reciprocal? Yes, you flip numerator and denominator. You flip this denominator and multiply with the numerator. So you are multiplying by x minus 1 divided by x squared plus x minus 6. So that's how we can make our complex fraction as a simple fraction. Write down the numerator. Okay, so here our numerator is, this part is numerator, so you just write down the numerator as it is. Do not change anything. Okay, then multiply this numerator by the reciprocal. Okay, by the reciprocal of the denominator. Reciprocal means you are switching numerator and denominator. Okay, so our x minus 1 is on top here. Okay, is the numerator, and x squared plus x minus 6 is the denominator. Okay, now this is very similar to the one that we just did. Let's factorize each numerator here. So x squared minus 4, we know the factor of x squared minus 4, that is x plus 2 times x minus 2. Let me write all this together. Okay, we are multiplying, means you multiply all the numerator. 2x plus 1, we can't factorize, so it's as it is. X squared plus x minus 6, we should be able to factorize. So x, bless you, x is the first term. What is the two number whose product is negative 6 and sum is positive 1? That is positive 3 minus 2. Now you look for the common factor. So x minus 2 is common. Do we have any other common? No, right? So you write down the remaining factor, x plus 2 times x minus 1 divided by 2x plus 1 times x plus 3. And this is the simplest rational expression for this complex fraction.